Hello again, class. Welcome to the first video of Chapter 2, and this is going to be about synapses largely, and we'll go ahead and get started. Whoa, okay. Not that way. Let me share my screen with you. There we are, and I'm going to go ahead and put that on the slideshow. Okay, so we're going to talk about Chapter 2, which is all about the synapse. Okay, so let's go ahead and get started. Chapter 2's objectives, we're going to start with objectives 1 and 2, but the rest of them are outlined there. You're going to be describing summation, which you know that word, it means addition, right? And then we'll outline the events taking place at the synapse, and then we'll distinguish some receptor types and so on. This is going to be the first 2 objectives in this video. So the first one is to be able to describe summation. Well, remember the word sum is in there, and that means addition, so you can imagine that as well. But I want to introduce you to the idea there that there's also subtraction involved. So, so you can kind of sum negative numbers, right? So summation is can be addition or subtraction. Okay, well, the question of summation is how do you get to the action potential, or how do you reach threshold? And so we have EPSPs and we have IPSPs, right? And so it's only EPSPs that are going to take us closer to threshold. IPSPs are going to make us more negative, they're inhibitory, and so they're going to take us further away from threshold. Well, there's a couple of different ways in which we can get to threshold using EPSPs. And one of them is temporal summation, and that's when a bunch of weaker EPSPs happen very quickly, and then that can add up to threshold. Or we have spatial summation, which means instead of in time, it's in space. So EPSPs coming from different sources can add up to threshold. Now, I want you to remember there's some subtraction in there, because if you get IPSPs, those are going to cancel out some of the EPSPs. So if I get a depolarization and then I get an IPSP, that's going to take me down, then I get another depolarization, I'm going to go up, another depolarization, I'm going to go up, and eventually, remember, there's going to be a level that's threshold, and that's where we get the action potential. Okay, so let's just take a look there at what happens with summation. So temporal versus spatial summation. Here we have an action potential, and that's the first box. We have an EPSP there. And with spatial summation, what you have is 3 different, you see there's 3 different neurons here, 3 different axons, and they're all connected to dendrite over here, this postsynaptic cell, and that is going to create, because they're all sort of happening simultaneously, it's going to create a large positive charge here. You can see on the bottom graph, and that might take you to threshold. So if those all add up from different sources. And then you can see here with temporal summation, there's only one source, but the action potential is happening rapidly over and over again. And then you can see that EPSPs here add up to eventually close to a threshold level depolarization there. Okay, objective number 2, outlining the events that take place at the synapse. So once we get an action potential that's shot down the axon, and remember that's going to go in that saltatory conduction all the way down the axon. Once we get to the end of the axon, and this is the presynaptic neuron, what happens there? And that's the question. There is a presynaptic neuron and then a space, and then the postsynaptic neuron. The synapse is that space in there. So the question is, what happens there when we get an action potential down there? Okay, well, it's a chemical process at the synapse. So in that junction, there's a chemical transfer between neuron number 1 and neuron number 2, or the presynaptic and the postsynaptic neuron. And so what's going to happen is your presynaptic neuron here is making neurotransmitters. And those neurotransmitters are little chemicals, and they're encased in these little bubbles in that neuron in the end of the axon. And those are called vesicles, okay? So that's where they're stored. So you got some chemicals stored in vesicles over here. Here comes the action potential down this neuron. And what's going to happen is at the end of this electrical potential, it's going to cause this neuron to spit out some of those chemicals. And then this neuron is going to pick it up, and this neuron, because of that, is going to have an EPSP or IPSP, okay? So at any rate, electrical potential comes down here. What is going to happen is that some calcium is going to come in. When calcium comes in, and that's at Ca+2, it's going to cause the release of the neurotransmitter, so the chemical transmitter into the synapse. And that we call exocytosis. Exo, like external, all it is a release externally of something, right? So action potential comes down here, calcium comes in, neurotransmitter released, and now it floats across the synapse over to this neuron. This neuron has receptors on the dendrites, and it picks that up, and it causes either an IPSP or EPSP over there, depending on what ions are taken in or pushed out, okay? So the transmitter is going to flow across that membrane and change the ion flow into the next neuron. Okay, well, I think we'll go ahead and do objective 3 as well. Distinguish receptor types. So there are 2 types of receptors. So here we're talking about the postsynaptic neuron. So we just released the neurotransmitter, it floats across here, and we're talking about 2 different kinds of receptors over here. So different neurotransmitters have different receptors. And those receptors can either be called, they're either called ionotropic or metabotropic. The ionotropic receptor, when the neurotransmitter hits it, the neurotransmitter kind of unlocks the receptor, and what will happen is it will let in an ion. So it might let in chloride, or it might let in sodium. If it lets in sodium, remember that's an EPSP. If it lets in chloride, that's going to be an IPSP. And so that neurotransmitter will cause this neuron, the postsynaptic neuron, to take in some ion. And the ion gates just opening very rapidly like that is the effect of the ionic neurotransmitter. And that happens with things sensations that happen very fast, like vision and hearing. We have a sense that happens very quickly. The metabotropic receptors, I won't make you know in great detail, but recognize that it doesn't just open the ion gate directly. It does it indirectly. So it's going to activate a second messenger in this cell, which is going to come back and basically reopen those gates. And that, because it takes a little bit longer to open the gates, to open the ion gates, we use that for senses, like, for example, taste and emotion. There's kind of more lingering or slow to warm up sort of senses. I mean, you may taste a jalapeno pepper and it may not feel hot at first, and then all of a sudden it starts burning. So it's because those receptors take a little bit longer. Here you see the ionotropic receptor. The neurotransmitter here will bind on to the receptor. And remember, the neurotransmitter never goes in to the postsynaptic neuron. It is just going to bind on there and open up a key, and then those ions come flowing in. That's ionotropic. It's real simple. It just basically opens the door to ions. Here we get a slightly different situation with the metabotropic receptors. And here's your neurotransmitter getting green, and it's made this change in the neuron that will eventually open up an ion gate, but it doesn't do it right away. All right, next time we will talk about inactivation and reuptake. Hope you enjoyed the video. Have a great day.